In this video, we're going to look at a few different scenarios for mathematically fairly dividing something. And so this first example is going to have to do with dividing up a pizza. So let's suppose that 4 people are splitting a $12 pizza with 8 slices. And also we have the information that the pizza is 1/2 pepperoni and 1/2 veggie. So we're going to answer a very, very easy question first, and that is, given no information, how can the pizza be fairly divided? Well, this means that there's no preference among any of the people depending on what kind of slices they want. And so how can it be fairly divided? I would say each person gets 2 slices because there are 4 people. So maybe we could say that. So each of the 4 people gets 2 slices. And then maybe we could even say 1 of each, because we're assuming no preference in this case. And obviously this is not an interesting example because preference is what makes the whole setup a little more interesting to work with. Okay, so now let's look at this other example which is kind of built off of this. So let's suppose that you like pepperoni twice as much as veggie. What is your fair share? And so that means this $12 pizza is not equally valued on either half. So notice that the half pepperoni is going to be valued twice as much as the half veggie, but then the total pizza still needs to be equal to $12. So you want to look for 2 numbers, one that is twice the other one that sum to 12. So that means the half that's pepperoni is going to be worth $8 and the half that's veggie is going to be worth $4. Now, furthermore, we know that there are 8 total slices, which means there's 4 pepperoni slices and 4 veggie slices. And so that means here each slice equals $2 because we've got $8 and then there's 4 slices. 8 divided by 4 is obviously 2. And then similarly here, each slice is $1. Now, let's go ahead and think about your fair share. And so notice the total value of the whole pizza is $12. We're splitting that among 4 people. So your fair share should be valued at $3. So now how can we do that? Well, there's a bunch of different ways that we can make a fair share for you valued at $3. And so one possibility would be 1 pepperoni slice plus 1 veggie slice. So that would be most definitely one possibility, because notice we've got $2 for the pepperoni slice, $1 for the veggie slice. That's a total of $3. Another thing you could do is you could take 1.5 pepperoni slices. Notice that 1.5 times 2 is 3. Again, that's a $3 value. And then the last thing that you could do is you could take 3 veggie slices. And I should not say the last thing, but just another possibility. You could also subdivide all of these pieces in more complicated ways to end up getting $3, but these are 3 of the possibilities. Again, notice 3 veggie slices at $1 a slice. That's going to be $3 altogether. So those are 3 possibilities for your fair share. Now let's look at another example built off of this. Let's say that one of the 4 people is a vegetarian and we want to know what their fair share is. So in their case, the half that's pepperoni is worth $0. And that's because, you know, they don't want to eat that at all. So that's going to be worth $0. But then the half that's veggie is going to be worth the whole amount, the whole $12. Great. But then there are 4 slices that are veggie. So this would be $3 per slice. Great. And then up here, we could do this, although it's not super interesting or important. These are worth $0 per slice because this person doesn't want them. Okay, great. Then the next thing to notice is that we have the same setup. This person's fair share is still $3. And so that means in order to get that fair share of $3, this person needs 1 veggie slice. but no other slices because they're valuing each veggie slice at $3. Okay, good. So I'll clean up the board and then we'll look at some more examples. Okay, our next example is exploring something called the Dividerchooser method when something is being divided among two people. And in this setup, one person divides whatever is being split into two pieces and the second person chooses whichever piece they want. And so here's the example we're going to look at. So you and a friend are given an apple pie and a chocolate cake. You value the pie at $6 and the cake at $4, and your friend values the pie at $4 and the cake at $10. And then you are going to divide into what you believe are equally valued portions, and your friend chooses. But notice, since these valuations are different, it's unlikely that you are going to split into portions that your friend also thinks are equally valued, unless you do kind of the easy choice, which is breaking it into two portions, each having half the pie and half the cake. So we could have half pie, half cake here, and then half pie and half cake here. In other words, two portions that are exactly the same, but then whoever does the choosing doesn't really have much of a choice to make because they're the same. So we're assuming that we have something a little more interesting than this. So let's look at two divisions. So maybe the first division I want to look at like this. So division number one. Okay, so remember, you are going to divide into what you think are exactly equivalent portions. So you'll do 1/4 of the cake. So that'll be one part of one of the portions. But notice 1/4 of the cake in your eyes is worth $1. But notice the total value in your eyes, maybe we should have pointed this out, that the total value in your eyes is equal to $10. Great. And so that means half of the value is equal to $5. So you're going to try to put this into two $5 portions. So that's going to be 4/6 of the pie, or 2/3 of the pie. That'll make the remaining $4 to be a total of $5. So let's say 2/3 of the pie. And that's going to be a total of, that's going to be $4, making a total of $5. So that's the first portion. And let's maybe put up here that this is your valuation is maybe in this column. Great. And then let's see what the second portion would be. So the second portion would be 3/4 of the cake, because that's what's left over. And notice that's equal to $3, and 1/3 of the pie, again, because that's left over, and that's worth $2. And so again, that's a total of $5. And so you value each of those portions at $5. But now let's look at your friend's evaluation of this. So your friend's value of this is going to be a little bit different. So 1/4 of the cake is going to be 1/4 times $10, because they think the cake is worth $10. So in other words, that's going to be equal to $2.50. Great. And then 2/3 of the pie, well, notice the pie in their eyes is worth $4. So we have 2/3 of the pie. So that's going to be equal to 2/3 times $4. But notice this is 8/3, which is like 2 2/3, and so that's going to be like $2.66. $2.66. So notice we've got a total of a little bit more than $5 in that first portion, as far as your friend's value goes. Okay, so now let's look at another way to divide this up. So now let's look at the other portion. So we've got 3/4 of the cake in this case. Again, they value it at $10, so that's going to be $7.50. And then 1/3 of the pie. So notice the pie is worth $4, so that's going to be $1.33. So now you could add those numbers up just to see which one's bigger, but it's actually pretty obvious in this case that your friend will choose this portion. Great, because they see that portion as being more valuable than the top portion, which means you're going to get the top portion. Okay, great. So I'm going to clean up the board, and then we're going to do a second division of this. So now we're going to do another division of this example, and recall that we're going to have a split in our eyes of this being worth $5 each, and then your friend is going to look at their value of it. So let's maybe do something extreme this time. Let's say that you make one of the portions contain all of the cake. So we'll say all of the cake is one of the portions, and that's going to be $4. But that means you need $1 worth of pie, and so that's going to be 1/6 of the pie. That's going to be worth $1. So notice that's a total of $5. Now let's look. The second portion would be 0 cake, because we need $0. We've already used up all of the cake, but then we've got 5/6 of the pie, and that's going to be worth $5. Great, and let's remind ourselves this is your valuation. So this is how you value these portions. You value them exactly the same. But now let's look at your friend's value. Okay, so your friend values this. Well, they're getting all the cake. They think the cake is $10. So that's going to be $10 for all the cake. Great. And then 1/6 of the pie, they think the pie is $4. So that's going to be 4/6 or 2/3. But 2/3 is going to be 66 cents. Okay, and now let's see what we have here. So no cake. So that's going to be worth $0 again, and then 5/6 of the pie. So that's going to be 5/6 times 4. So that's going to be like 20/6, which is the same thing as 10/3. And so that's like 3 1/3. So that's going to be like $3.33. So in this case, your friend would obviously choose this because they like the cake a lot. Okay, good. I'm going to clean up the board, and then we'll look at another one of these ways of dividing things up. Okay, our next example is going to look at something called the lone divisor method. So it breaks into 4 steps. So the divider divides n pieces, and so the whole setup here is you've got n people that you're dividing something among, and one of them is chosen to be the divider. The divider divides whatever you're dividing into n pieces, and that person believes all of those pieces are of equal value. Then the next thing that happens is that the choosers separately list which pieces they choose to be fair. And then next, if possible, each chooser gets a piece that they consider fair, and the divider gets the remaining piece. Now this may seem unfair to the divider, but the divider did divide everything up into something they think is equal, so the remaining piece has equal value to all the others in their eyes. Then finally, if this step 3 is not possible, then a non-contested piece goes to the divider, and then the whole thing repeats where someone else is chosen to be the divider, one of the remaining people. Okay, so let's say we have this setup. These people A, B, C, and D are dividing something, and D is chosen to be the divider. And then the valuations of the parts are given in the following chart. And so these are read to be percents. So 100% would be the value of everything put together before it has been divided. So notice D divided everything into 25% chunks. So they divided everything out equally, which was their goal. And then A values part 1 at only 15% of the total, part 2 at 30, part 3 at 20, part 4 at 35, and then B, part 1 at 30, part 2 at 35, part 3 at 10, and part 4 at 25. And then finally C values part 1 at 20% of the total, part 2 at 45% of the total, part 3 at 20, and part 4 at 15. So let's see which parts each person considers fair. Okay, so let's first look at person A. So since there's 4 people, anything considered fair would be 25% of the total or more. So notice person A considers part 2 30% of the total, and part 4 35% of the total. So each of those is bigger than or equal to 25% of the total, so those are considered fair. Now let's look at person B. So person B considers part 1, 2, and 4 each more than or equal to 25% of the total. So those are all fair in person B's eyes. Then finally, person C only values part 2 at more than 25% of the total. So they will only be okay with part 2. Now looking at that, we see, is it possible to do this third step? And it is possible to do this third step. In fact, if we give C part 2, then we'll have to give A part 4, then we'll have to give B part 1, and then the leftover part will go to D, which is part 3. So that would be like a fair division of this in this setup. Okay, good. So I'll go ahead and erase the board, and we're going to look at a couple more of these fair division rules. Okay, for our next example, we're going to look at something called the last diminisher method. So it goes through the following steps. So you've got something to divide, and you randomly assign people an ordering. And so it goes first person, second person, third person, fourth person. And the first person cuts a slice as they see fair. So they try to cut off exactly a portion which would make the whole thing fair. And then the second person looks at the portion that's been cut off, and there are two things that can happen. They can think that it is worth less than or equal to the fair price. And if that's the case, then they're going to pass. Or they could think that it's worth more than the fair price. And in that case, they're going to trim it off until they think it is fair. So let's say the first person cut too big of a slice, then the second person is going to cut that slice off to make it fair. Then this is going to repeat for the remaining people. And then after the last person has decided that it's fair or cut it, it goes back and looks at the last person to have trimmed the slice, and that person gets it. And then you put all of the trimmings back together, and you repeat the whole game with one less person. And so that's going to continue until there's only 2 people, and then finish off with the Dividerchooser method, which we looked at before. Okay, so the game we're going to play has 4 people in it, A, B, C, and D, and they're going to go in that order. So A is the first person to go, and then B, and then C, and then D. And they're splitting a $12 pizza, so 4 slices are cheese and 4 slices are veggie. Now, A and B like each equally, and so they consider cheese and veggie to be the same. C only likes cheese, and D likes veggie twice as much as cheese. Okay, so let's see, A is going to go first, and they're going to cut something off which they see to be fair. And let's say, since there are 8 slices altogether, they are going to cut 2 slices of cheese. So notice they see that as a value of $3, which is fair in their mind. Okay, then the next thing goes to B, and B decides, hey, was that a fair cut or was that an unfair cut? And they see that as fair and passes. Good. And then C looks at it, and then since C only likes cheese, they're going to think about the value of the pizza only being in the cheese part. And so they're going to value this at $6. And we know it's $6 because each piece of cheese pizza in this case is worth $3. And so what they'll do is they will trim off 1 piece. Great. And so now that's going to leave a value of $3. Okay, good. So now the next thing that D is going to do, and look at this and say, hey, I like veggie twice as much as cheese, so 1 piece of cheese pizza is definitely less than the fair value, so they're going to pass. And then we're going to look at the situation and see who was the last person to go. The last person to go was C, and they're going to get the piece that they chose, which was 1 piece of cheese pizza. So that's the result of round 1. So C gets 1 slice of cheese. And so let's go ahead and write that up here. So gets 1 slice of cheese. Okay, great. And now we're going to erase this and look at what happens in round 2. So now we're in round 2. So let's just see what's left over. We have 3 slices of cheese and 4 slices of veggie left over. So let's say that A goes first still, but notice C is out of the game at this point. So A is going to cut 2 slices of veggie. And so notice that's a total of $3 in their minds because the veggie and the cheese are equally valued in this case. Now let's go ahead to B. So B views veggie and cheese equally, and so they're going to look at these 2 slices. Well, notice 2 slices is 2/7 of the pizza, but that's more than 2/6 of the pizza which is left over, and so they're going to cut just a little. And so what we need to do is take 2/7 down to 2/6 of the pizza, which is 1/3 of the pizza. So it's actually not important to do this super carefully, but I'll let you guys check what that is if you want to do it super carefully. And then it goes to person number D. Okay, so now notice that D likes veggie twice as much as cheese, so they're going to think that this is worth more than the cheese that was left over, and so they're going to again cut a little and claim. But then since he's the last person in the game and he cut it, and remember the last person to trim gets it, then this person gets 2 slices of veggie. And I should say maybe like 2 minus slices of veggie. It's just a little bit less of 2. So let's go ahead and write that up here. So gets 2 slices veggie. And now we're ready to go on to the 3rd round. So I'll clean up the board and then we'll do that. So now we're in round 3. We've got 3 slices of cheese and 2 slices of veggie left. And now, since there are only 2 people left, A and B, we can use the Divider-Chooser method. But in this case, it's not super interesting because they like each of these types equally. And so the Divider-Chooser method means that whoever divides will divide into equal portions that the chooser also equally values. So there are a bunch of examples for how to divide this equally in terms of the divider, which in this case will be the same as in terms of the chooser, but maybe one example would be 1 portion, which is 1.5 slices cheese. So 1.5 cheese and 1 veggie. And then another portion which is the same. So that would maybe be the cleanest way to finish this off. Okay, so I think this is a good place to stop.